Imagine a static point source that radiates force outward in every direction, much like light from a star. Because this field flows away from its center without any gain or loss in the space around it, it mathematically necessitates the existence of an underlying vector potential. This potential acts as the hidden blueprint that generates the visible outward force. The physical manifestation of this potential is not a straight line, but rather the geometry of an azimuthal swirl. Even though the field lines we observe push directly outward, they are actually being generated by this vortex-like potential circulating around them. This creates a fascinating tension between the straight path of the force and the circular path of the potential. This tension reaches a breaking point when you try to apply the swirling motion to the entire surface of a sphere. It is geometrically impossible to wrap a perfect circulation around a sphere without encountering a snag. This results in a topological defect known as a Dirac string. This string is a specific line or point where the mathematical description of the potential simply cannot exist. Because of this inevitable defect, a point source potential cannot be globally well defined on a single coordinate map. Instead, it must contain a mathematical seam to properly account for the total outward flow of the field. Interestingly, the location of this seam is not fixed. Through parameter shifting, a scientist can move the singularity between the poles of the sphere. While this shift changes where the mathematical snag is located, the physical field remains entirely unaltered, proving that the seam is a requirement of the geometry of the potential rather than a change in the force itself.